So this is 5.2 proofs, so we're going to go through 4 proofs. Okay? You're always going to start with your statements and reasons, and then your first step, you're always going to copy down the givens that they give you. So I just copied and pasted for the sake of time, and your reason for both of these is that they gave them to you. Now you always want to make sure that you mark down your givens in the picture. So AD, segment AD is congruent to segment DC. We'll mark that in our picture. And then the second step is either the reflexive property or vertical angles. In this case, we have the reflexive property because side DB in the left triangle is congruent to side DB in the right triangle because they happen to be the same side. So we can say that segment DB is congruent to segment DB, oops, by the reflexive property. Okay, the next step, you want to look at your givens and say, what information do I know because of my givens? So the first given is that segment DB is the segment bisector of segment AC. So segment DB is doing the bisecting and it's cutting segment AC in half. So here's segment AC and DB is cutting segment AC in half. So that means this half, AB, is congruent to this half, BC. So segment AB is congruent to segment BC. And how did we know that? By definition of segment bisector. Because that was our first given, right? Here it's bisecting segment AC. Since segment AC is getting bisected, it is definition of segment bisector that told me this half was equal to this half. Now we have side, side, side of one triangle congruent to side, side, side of a second triangle, and therefore by the side, side, side congruence postulate, I can conclude that triangle ABD is congruent to triangle CBD, which is what we were trying to prove. Here we have the given that S is the midpoint of segment QU and segment RT. So there's actually kind of two givens there. Okay, if S is the midpoint of segment QU, I'm going to highlight QU, and that means S is in the middle. So that means that this half of QU is congruent to this half of QU because S splits it in half. So we know that segment QS is congruent to segment SU by the definition of midpoint, since S was the midpoint of segment QU. Then we have segment RT. So let me highlight segment RT, and we know that S is the midpoint of segment RT, which means this half is congruent to this half. So segment RS is one half, is congruent to the other half, which is segment ST. And again, that's by definition of midpoint, since we knew S was the midpoint of segment RT. There's no reason I used 2 tick marks and then 3 tick marks. We could have used 1 and then 2. And now we want to check, do we have reflexive property or do we have vertical angles? We have a pair of vertical angles right here, and vertical angles are congruent. So be careful when you name these angles. We can't say angle S because there's really 4 angles at the point S. So we can name this angle QSR. And then to make sure you get the corresponding angle correct, you can use your congruence statement. So QSR is corresponding or congruent to angle UST. And if you come over here, QSR is congruent to UST. And that'll be useful for what we get to later in chapter 5. And this was, we knew that they were congruent because they are vertical angles. So last but not least, we can prove that triangle QSR is congruent to triangle UST by the side angle side congruency postulate. And the important thing to note here is that A is the included, sorry, not A. This angle is the included angle between this side and this side. Okay, so it's the included angle, meaning it's the angle that's between those two sides. And that allows us to use SAS to prove the two triangles are congruent. So here they told me that ZT is parallel to RP, so I'm going to just mark that with two arrows in our picture. And next they told me that ZT is also congruent to segment RP. So I'm going to mark those congruent with one tick mark. And those were both given pieces of information, and I marked them in my picture. Now, anytime, let me pull up this proofs guide for you. If you've never seen this before, this should help you to write proofs. You're always going to have some givens. Most of the time, you're either going to have the reflexive property or vertical angles. And then, based on what your givens are, you're going to know some piece of information. So if you're given a midpoint, you're going to know something by the definition of midpoint. If you're given a segment bisector, you're going to know something by the definition of the segment bisector, etc. So if lines are parallel, which we have in this example, then we know alternate interior angles are congruent. We know some other things too, but in this class we're going to be dealing with a lot of alternate interior angles. So if you look, we can picture this as our, actually let's start with reflexive property. So we know that segment RT in this top triangle is congruent to segment RT in this bottom triangle because they're the same side. So we can say RT is congruent to segment RT by reflexive property. Okay. Now let's picture RT as our transversal, and I'll just extend this so you can see better that these are my two parallel lines and RT is my transversal. So we actually have two sets of alternate interior angles. We have alternate interior angles here on the insides of my lines and opposite side of the transversal. And we also have alternate interior angles here. Now we only care about one pair of them for our proof. And the reason for that is because we only need one pair to prove the triangle's congruent using the side angle side congruency postulate. So if I want to use side angle side congruency postulate, right now we have a side and we have this side, so we need the included angle between those two sides. So we'll look at this angle, and if you look over here, the alternate interior angle is right here, and those are congruent. So that is also the included angle between these two sides. So now, by SAS, I can prove that my two triangles are congruent. So let's write that step down. This is angle ZTR, which is congruent to angle, so you can use your congruency statement to make sure you get it right. ZTR corresponds to PRT, so angle PRT. So you can see ZTR is congruent to angle PRT. And that is by alternate interior angles are congruent. So I'm okay with you using this shorthand, abbreviating alternate as ALT, interior as INT, angles, symbol for angles, and congruent for congruence. And then now we have all three components, right, to say that by side angle side congruency postulate, my two triangles, ZRT and PTR, are congruent. Last, we have two givens. This should actually just say segment AB because it's not array. So segment AB bisects angle CAD, and side AC is congruent to side AD. And those are both givens. So let me mark the second one in my picture. AC is congruent to segment AD. All right, second step, if we look at that proofs guide, all right, second step, do we have reflexive property or vertical angles? So let's look. We have the reflexive property. We know that AB is congruent to AB because it's the same side in the left triangle and the right triangle, right? Of course, it's congruent to itself because it's the same side. So AB is congruent to side AB by the reflexive property. So right now we have a side and a side. So if you look back up to the first given, AB bisects angle CAD. So that is an angle bisector because the angle is what's getting cut in half. The segment AB is doing the bisecting, but the angle is what's actually getting cut in half. So we're going to have some piece of information by the definition of angle bisector because our first given is an angle bisector. It cuts angle CAD in half. So we know that this half is congruent to this half. So now we just need to name those angles, right? If you are going to write definition of angle bisector, then you better have an angle is congruent to an angle. Okay, don't write segments and say definition of angle bisector or vice versa. That doesn't work. So this angle, this half is angle CAB. And that is, so angle CAB is congruent to angle DAB. You can see that in your picture as well. DAB is this other half right here. So now we have side, angle, side, side, angle, side. So we can say by the SAS congruency postulate that triangle ABC is congruent to triangle ABD.